Hello, Honors Chemistry. Here is number 23 from Chapter 15, Chapter Review. These are a little difficult, which is why I want to go over them, okay? This one goes with solubility product constant, the KSP. When you dissolve something in water, it goes to equilibrium. Some of the solid will stay if it's saturated, and these will break into their ions. And not everything is 100% soluble. I mean, something like NaCl is 100% soluble, but a lot of these things are not 100%, so they have what's called a KSP number. This is on a chart that's in your chapter, and the lower it is, the less soluble it is, okay? Because if you look, that's the concentration here. So when there's more concentration here, and this is a bigger number, that means more of it has dissolved. So if you look at these two things, this one is not nearly as soluble as this, because negative 12 is a very tiny number. 10 to the negative 12 is a very tiny number. So this is not very soluble. This isn't really super soluble either, but in comparing the two. So the first thing you would do in a solubility problem is to write its solubility equation. Take the solid they give you, write your equilibrium, and put your ions. Then write your KSP expression. Remember, if there's a 2 in front, then it becomes squared. And don't forget, the solubility will be doubled when you plug it in. So if they give you the solubilities, you will double it before you put it in, because there's double this amount at equilibrium as there is here in the equation. So let's take a look. They give us these two, and they ask, when you mix them in equal, that's very important, in equal amounts, will a precipitate happen? So what we want to look for is whether or not, when we mix them together, when we plug in the numbers here, if it's less than this number, it's not going to precipitate, because there's not enough, it's not up to its solubility. If it's greater than the number, it will precipitate. So let's take a look. First of all, you have this many moles per liter of this. So, and then you have this many moles per liter of this. Notice they have a common ion. They both have Mg. So since they're poured in even amounts, to find out how much Mg, the molarity of the Mg in the solution you put together, you have to average these two. So if you add it together and divide by 2, you get the molarity of the Mg. Now the other ones are just, if there's only one in each one, then it's the same as the molarity. So the CO3 would be 6.3 times 10 to the negative 4, because for every mole of MgCO3, there is 1 mole of this and 1 mole of that. So it's going to be the same as this. Now, if you look over here, for every mole of magnesium hydroxide, you have 1 mole of Mg, but you have 2 moles of OHs. So when this splits up, you're going to have double that amount of molarity of OHs. So you do that times 2. So the molarity of your OHs is there. So now you have what you're going to plug into your solubility product constant. So if I plug in 3.7 times 10 to the negative 4 in for that, and 6.3 times 10 to the negative 4 into that, I get 2.33 times 10 to the negative 7. Well, look at this number. That's smaller than this number. So it's less than KSP, so it will not precipitate, okay? Now let's plug in this and this to this. So you put in 3.7 times 10 to the negative 4 times 2 times 10 to the negative 4 squared, and you get 1.48 times 10 to the negative 11. Well, negative 11 is greater than negative 12, so it's greater than the KSP, so this will precipitate. Okay? So if you go and look and there's no KSP for something, like if you go and look at a chart and there's no KSP listed, that means it's 100% soluble and nothing will precipitate. Okay, so that's how. That's just a hint for one of them. So I've done B. So see if you can do C by yourself and A as well.